Hello my friends and welcome back to the final step of this implementation of the upper confidence bound algorithm. We actually already implemented the algorithm itself in this cell implementing UCB, and now we can just sit comfortably in our chair and visualize the results, because indeed implementing this final step will be super easy. We just have to plot a histogram and make a nice title to the chart and also some labels for the x-axis and the y-axis. So let's do this. Let's create a new code cell here. I'm gonna scroll down a bit, all right? And there we go. Let's plot that histogram. So just to make sure we all understand, this histogram will plot for each of the ads, well, the number of times it was selected. So on the x-axis, we will have the different ads, from not 1 to 10, but 0 to 9, because we work with indexes and they start from 0. And on the y-axis, we'll have the number of times each of these ads was selected. All right, so the good news now is that, we already have the tool we need to plot such a histogram, which is matplotlib.pyplot. And for this, we gave the shortcut name PLT. So that's what we're going to start with. PLT, calling matplotlib.pyplot, and from which we're going to call a specific function from this pyplot module, which is the hist function. And as you might guess, well, this hist function can plot any histogram. All right, so let's add some parentheses. And now, according to you, what do we have to plot in this hist function? Well, that's actually easy. If we scroll down here, you can see the parameters. The only parameters that we'll need is this one, x. And this is supposed to be, either an array or a sequence of arrays. Basically, it's going to be a list of values, which will be the values on the y-axis of the histogram, right? And therefore, what we simply need to input here in our histogram is, this variable ad selected, which we created, which contains indeed the sequence of ads that were selected over the round. So keep in mind, ad selected is a list of 10,000 elements, where each element is the ad that was selected at a particular round. The nth element of this ad selected list is the ad that was selected at round n, shown to the user n, all right? And this is exactly what is supposed to be the input of this hist function. So let's just paste that inside, and there we go. Basically here, the job is done. This will plot the histogram. However, of course, we want to make it nice. And to make it nice, well, we will just add a title to this plot, and we will choose, in quotes, this title to be histogram of ad selections. All right. Then we're going to add a nice label to the x-axis, and the function for this, remember, is xLabel, same as the plot function actually. So xLabel, and in parentheses, well, we'll give in quotes a nice label to the x-axis, and since the x-axis corresponds to the different ads, from 0 to 9 because of the Python indexes, well, we'll set this xLabel as ads, okay? Then same for the y label, and in parentheses, we will enter in quotes, well, this time, well, let's make it very clear, let's just input number of times each ad was selected. All right, so that it is 100% clear. And finally, remember, we have to end with plt.show to display the graph in the output of the notebook. Okay, so we're done. Do you understand what is expected here, right? In the histogram, it is expected, if the UCB algorithm was powerful, it is expected that one of the ads was selected the most, was selected way more than the others. Because the goal of the UCB algorithm is to quickly, is to as fast as possible identify the ad that has the highest CTR, and once it is identified, well, only this ad will be selected. Okay, so we should see one ad that was selected way more than the others. In other words, we should see one bar in the histogram that is way higher than the others. Are you ready? Let's play this cell, and there we go. We got what we want. Indeed, this ad of index 4 here, meaning the ad number 5, was clearly the ad selected the most, therefore was clearly the ad with the highest click-through rate. And in terms of our business case study, it corresponds indeed to the ad that is the most attractive, meaning the ad that has the most beautiful image of that car that will sell the most to the users or future customers. Okay, so good job. the UCB algorithm did a very good job here. However, remember that, the goal is in fact to, identify this add as fast as possible, in a minimum number of rounds. And therefore, what we should experiment right now, it's not quite over. We should experiment to see in actually how many rounds the UCB algorithm was able to identify this add with the highest CTR. And the way to check this is by, changing that value of n here, because this algorithm was run with 10,000 rounds. But what if we put instead, 5,000 rounds? We would like to see if the UCB is still able to identify that add of index 4, with the high CTR in 5,000 rounds. So that's exactly what we're going to check now by, rerun everything. And the way to do this is by clicking runtime here and then restart and run all. And we're going to see if with 5,000 rounds, well, that UCB algorithm is also able to quickly figure out the best add. And yes, very good. Even with 5,000 rounds, with 5,000 users, the UCB was able to identify the add with the highest CTR. And now let's make it even more challenging to the UCB. Let's replace 5,000 here by 1,000. And let's click runtime again and restart and run all. And let's see if with only 1,000 rounds, well, the UCB is able to, wow, okay, so it was still able to do it, identifying the add with the highest CTR, which is still, of course, add of index 4, but quite just, So now I, of course, want to try with 500 rounds, right? We're going to replace that 1,000 here by 500, then rerun everything by clicking restart and run all. And now let's see, but I'm not sure, right? Let's see if it is still able to identify that add with the highest CTR, and that's what I'm talking about, 500 rounds is not enough for the UCB algorithm to identify that best add, that add with the highest CTR. Because indeed, the add with the highest CTR is clearly add number 4, but in 500 rounds, the UCB identified the best add as add of index 7. So 500 is not enough. And so now it will be very interesting to see with the Thompson sampling algorithm if it can beat the UCB algorithm in the sense that it can find this add of index 4 with the highest CTR in 500 rounds. Because the UCB can clearly find it in 1,000 rounds, that's for sure, but not in 500 rounds. So we're going to see with the Thompson sampling algorithm if this one is able to find that best add, because we're going to work on the same data set, of course, if it is going to identify that best add of index 4 in 500 rounds. And if yes, we will even try lower numbers of rounds. So I can't wait to now implement Thompson sampling with you. We will work on the exact same data set, so we will just compare. So let's do this in the next section, and until then, enjoy machine learning.